also fix the lambda, because it's always easier for you to fix the lambda and change the direction of the sample or the X-ray. Okay. So powder diffractometer method, similar to the Debye method, the firm is replaced by counter. The counter position is varied around the powder specimen. The incident angle omega is defined between the X-ray source and the sample. The diffracted angle 2 theta is defined between the incident beam and the detector angle. So the incident angle omega is always half of the detector angle 2 theta. So this is how it works. So the result is something like this. So you get 20 degree, 30 degree, then this one maybe 36, this one 42, then this one 46. So for all these peak, you can see that we have peak at 20 degree, and peak end of 20 degree is actually referring to the plane 100 plane. Okay, so if like for the second case, the 110 plane would diffracted at 29.3 degree. However, they are not properly aligned to produce a diffraction peak. That means that the perpendicular to this plane does not bisect the incident and diffracted beam. Only background is observed. And then for 200 plane, the 200 plane are parallel to 100 plane, therefore they also diffract for this crystal. Since the 200 plane is half the 100 plane, then it would double the value. It's about 40 point something. Okay. So basically, it's a very basic technique to show that okay, this peak is correspond to 100 plane when it reflect at 20 degree, about 20 degree. When reflect at about 29 something, 29.3 is actually referring to 110 plane. So I know that okay, 110 plane that got one atom. Okay, at 111 plane that got atom, 200 plane that got atom, 210 plane that got atoms. Then now I can I can deduce what is the background, what is the structure of it. Okay. So okay, this one because during that year I just share what is the Nobel Prize in Physics for that particular year. Okay, so there are many Nobel Prize winners associated with this crystallography field. The Nobel Prize is an international award administered by the Nobel Foundation in Sweden. It has been awarded every year since 1901 for achievement in physics, chemistry, physiology, or medicine. Literature, and for peace. Over the course of its history, many awards have been made for scientific achievement directly related to or involving the use of cryptographic method and technique. So, if I'm not mistaken, there are more than 18 Nobel Prize award is related to this crystallography. Okay, the reason why in 2012 for the study of G protein coupled receptor. 2011 quasi crystal. I have mentioned it in symmetry chapter. Then 2010 the two-dimensional material graphene. 2009 the structure and function of the ribosome. 2006 molecular basics. 2003 potassium channel. 1997 elucidation of enzymatic mechanism. 1996 fluorine form of carbon. 1994 neuron diffraction. 1992 multi-wire proportional chamber. 1991 polymer and liquid crystal. 1988, determination of three-dimensional structure. 1985, direct method for the determination of crystal structure. 1982, crystallographic electron microscopy. 1976, structure of borane. 1972, folding of the protein chain. You see there are many. Okay, we have structure of biochemical substance, the structure of DNA, protein, nature of the chemical bond, enzyme, diffraction, knowledge of molecular structure, wave nature of the electron, characteristic Röntgen radiation, X-ray to determine the crystal structure, Bragg law, and then diffraction of X-ray, and then discovery of X-ray. So we can see there are many Nobel Prize awards which are related to X-ray crystallography. Okay, so we can see how important it is in the development of scientific field. Okay, these are the tutorial. So you can do the cell test by proving the Bragg law using delta K equal to G. Why is X-ray the best choice to study the molecular structure of a compound? It compared with the neutron and electron sources. I want to explain it. Amongst more lead and copper X-ray sources, which give a better intensity when the same energy applied, and why? I want to calculate the wavelength of neutron radiation when E equal to 0.08 electron volt is applied. I want you to define diffraction, explain the importance of diffraction to elucidate the crystal structure. Okay, so that's all for this chapter. Then we'll proceed to the next chapter, chapter 6.